I'm joking. I like it when you guys ask questions. All right, what should we use PSSA on? Radical. What about CO? No, not a radical, is a product. Okay, just testing you. So the rate of the CH3 radical is R1 plus R3 minus 2 times R4. Why is it 2 times R4? Because, yeah, there's a 2 over there. R1 minus R3. Again, you see that there's a slight benefit in adding them together, right? The R3s cancel. So test-taking strategies, sometimes, often, it makes sense to add these two together. They're both equal to 0 or approximately equal to 0. So the sum is also approximately equal to 0. The R3s cancel. And so I can write that 2 times R1 minus 2 times R4 Everybody knows why it's 2 times R1?
You added it.
Huh?
You added it.
Because we added it. Yeah, this is not from stoichiometry, okay? Don't let it throw you off. It's about equal to 0, so we get 2 times K1 times this. In some sense, it's from stoichiometry because you're making, never mind. Minus, squared. Everybody knows why it's squared?
Dr. Rhodes, I have a question.
Yes.
For the rate CH3 dot R1 plus R3, yeah, that equation. Why did you include R3 as a, I guess, a what is it, a production or production equation, not a consumption? Because CH3 is on both sides of the, so it's not being consumed or produced. That's why I'm it's kind of just participation.
It's because it's only on the left.
Okay.
It's an irreversible reaction. Oh, no, you're asking about R2. R2 is not written. I didn't write it. That's why.
So you don't include it?
I didn't.
Because it's not being produced?
Yeah, it's not there. Yeah, it's R3. It's being produced in R3. Yeah, I should have pointed that out, though.
What did you end up writing down?
So, CH3, right? I'm just rearranging this equation. So what do I get? K1 over K4 to the 1/2 and concentration of acetaldehyde to the 1/2. And now I can write come back to here, but now we're going to actually put things in. K1, right, times acetaldehyde plus K2 times the methyl radical times acetaldehyde plus K3 times the formal radical times acetaldehyde. So we now have an expression for the methyl radical. How do we get one for the formal radical?
Just go back up.
And so I just rearrange CHO K1 over K3. Everybody see that? The acetaldehydes cancel. So now I'll substitute those in. K1 times acetaldehyde plus K2 times what? My expression that I got for the methyl radical is K1 to the 1/2 K4, I believe, to the 1/2 times acetaldehyde to the 1/2 times another acetaldehyde. So this becomes what? 3/2 plus K3. What's CHO? It's just K1 over K3. So K3's cancel, right? K1, K3, they're going to cancel. And then you get acetaldehyde again. So just a little bit of simplification. This is K1 times acetaldehyde. This is K1 times acetaldehyde. So that's 2 times K1 times acetaldehyde. We already did the 3/2 there, so we just get the same thing here. K2, K1 to the 1/4. No, sorry, 1/2. K4 to the 1/2. So that's my final rate equation, okay? The last thing to do before we leave, you're going to tell me at what conditions will that be true? And at those conditions, what will K effective be? Yeah.
When K1 is less than 2K1, A is negative really small.
Say that again.
When 2K1 times AC is really small.
When that whole thing is really small?
Yeah.
No, unfortunately that's not right. Yeah.
Wouldn't it just be when K1 is really small because K effective would still be K effective?
So you guys keep trying to make this term go away.
What if K2 is equal to K4?
You don't want to make this term go away. You got to do some math first.
K2 over the square root of K1 over K4 has to be much larger than 2.
Yeah, we got to do a little bit more work first. So what do we do before I can do that? Does this look like that? No. Why not? Right? It's not in terms of 3/2, and I can't just make this whole thing go away. What you're going to end up with is similar. But the mathematically rigorous way to do it is that first we want to rearrange it to make it look something like this. This already is in here. So first thing we want to do is divide through, okay? So that we can write it in terms of, and now I'm rewriting this equation, not this one. We want to bring this out. And now what do I multiply this by to get this? So first, this term, right, it's pretty simple. Just multiply it by this grouping of rate constants. Now this term is what? 2 times K1 divided by the square root of the acid-aldehyde concentration. Does everybody see how you go from there to there? That's what you want to do, and now you have the right form of the equation, where now it's this inequality that matters. So, to get this form, right, which of these terms needs to be big? These, right? This has to be much larger than this. And that satisfies So if you compare that difference with the difference that you'd kind of first shouted out, which is just make that first term real small, you'll see some pretty big differences, right? You still have, this is the same. But you guys said that it needed to be bigger than this.
No, we have the left term multiplied by AC to the 3 halves.
Yeah.
Yeah, the left side would be multiplied by AC to 3 halves.
Right,
because it's
right.
not balanced.
But we don't want, there's no reason to leave the AC to the 3 halves on both sides of the inequality.
But it's the same equation.
Yeah, mathematically you're right, but yeah, you wouldn't want to leave that inequality as written.
I mean, if you simplify the equality,
Yeah.
it's the same thing.
If you, right, so I'm just saying, make sure that you're simplifying the inequality. And often you're going to want to write the rate equation like this anyways. But you're right, it would have ended up the same. Okay, so any questions about that? Okay, that's it for today. Office hours will be tomorrow with the TA, period 7 through 8.